We're talking about properties of rational exponents, and we want to use properties of rational exponents to simplify expressions with rational exponents. We want to change each expression from exponential form to radical form. So we need to keep our base the same. So we're still going to have 3m. And then anything that's in the denominator ends up going on the index of the radical. So we make the radical sign, and anything that's in the denominator is the index number on the radical. And that whole thing is raised to the first power, and we don't have to do anything with that because if it's not written down, then we understand that it is 1 there. The next one that we have is 10v raised to the 1/3 power. So we're still going to write down our base is 10v, and anything that's in the denominator goes on the index of the radical. So in this case, our denominator is 3, so we're going to take the cube root of 10v, and if we have a 1 in the numerator, we can just leave it as 1. Then we go to number 6, and we see that we have a negative 3/2 power. So in order to make that positive, we're going to use the negative exponent rule. So we're going to move that to the denominator, and we get 5a, and that whole thing is raised to the negative, or excuse me, this is going to be positive 3/2 power. And now that we have it as a positive exponent, we can write it in radical form. So we're still going to have our base, which is 5a, and we are still going to have our divide sign and our 1. Anything that is in the numerator is going to stay in the numerator. Oh, yep, it's going to stay in the numerator. So anything that's in the denominator is going to be on our radical. Now, if it is squared, we don't have to write it down. We don't have to put the 2 there because anytime it's squared, we understand it's squared if it's just written as just the radical. And then that whole thing is going to be raised to the 3rd power. So 1 over the square root of 5a raised to the 3rd power is the same as saying 5a raised to the negative 3/2 power.